So before we get into our speakers' presentations and the details of the workshop, I just wanted to give a little bit of a background into kind of the catalyst for today's workshop. So first off, my name is Colin Huffine. I am the watershed coordinator for Huntington County Soil and Water Conservation District's Lower Salamone River Watershed 319 project. It's kind of a mouthful, but that project was primarily focused on providing cost share money to producers in critical areas of the Lower Salamone River watershed in terms of aiding in technical and financial assistance to implement best management practices like cover crops, no-till or reduced-till farming, grassed waterways, filter strips, as well as equipment modifications and various other practices as well. So through that project, we were able to fund over 70, nearly 80 projects and funded just shy of 6,000 acres of cover crops. So we're very pleased with our efforts and the amount of conservation-minded farming that we've seen growing in the Salamone watershed. So another prominent component of that project is an education and outreach program. And so it's geared toward, on one hand, educating the general public about non-point source pollution and water quality issues, but also toward providing education and content for producers and landowners in terms of implementing best management practices as far as their benefits to soil health and water quality, as well as the benefits to their farm system. So that was kind of the catalyst for today's workshop, was to provide some information on soil health, some of the basic elements and components of soil health and how that can be applied in your farming system. So we have a great lineup of speakers today and presentations I'm really excited to hear from. First off, I just want to take a second to thank Sheila Schroeder from CCSI and Ed Ferris as well with Purdue Extension for helping to organize this and facilitate the workshop, and just really appreciate your efforts in getting this organized. So, but as I mentioned, we do have a fantastic lineup of speakers, including Stephanie McLean, Joe Rorick, Jim Camberato, and Ed Ferris. So the way today's workshop will sort of be structured or scheduled is we will hear first from Stephanie, and then Joe, and then Jim, kind of back to back to back in consecutive presentations. And then we'll open it up for about a 10-minute or so question and answer session, which you'll be able to provide questions that you may have into the Zoom chat, which Sheila might mention here in a moment where that's at. But you can direct your questions specifically to one of the speakers or maybe to the group as a whole. I'll leave that up to you if you have questions. But after that Q&A session, then we'll finish with Ed Ferris and his presentation before wrapping up the workshop. So thank you all for joining today. I really appreciate our speakers taking time out of their day to come and provide some great content for all of you. And thank you to all of you in attendance for coming and hopefully getting to learn something today about soil health. So with that being said, one other topic that comes to mind that maybe I need to address is PARP credits. If you have any questions about PARP credits, they are available for this program. So if you registered for those and you're in attendance, you will receive those. If you have any questions specific to PARP, you should contact Ed Ferris directly. He'll be the go-to on that. I know we mentioned yesterday, Ed, that we may have some people that have registered for PARP that may be sharing a computer today or attending together on one computer. If that pertains to you, please reach out to Ed and let him know that that's the case so we don't miss your name on the list of attendees. So please reach out to Ed, let him know if you're sharing a computer so that we can count you as being in attendance so you can receive your PARP credits. With that being said, I am going to turn it over to Sheila Schroeder, who is the North Program Manager of CCSI, to give a brief overview about the Zoom platform and some of the basics of Zoom and some of the functions within Zoom that will help you if you're unfamiliar, kind of familiarize yourself with Zoom and make for a kind of a smoother workshop moving forward. So thank you.
Thanks, Colin. We're showing you some slides right now that show you some of the features of Zoom, as Colin mentioned. And if you're on a PC or Mac, over to the lower left is where you'll find your microphone and video settings. So most likely you are all muted, as most of us are not speakers for this event. And it's just a simple click onto the mute or unmute to take care of that, as well as next door, the start video, or you can unclick that to turn off your video. If you have limited bandwidth, it might be better for you to turn off your video to get a better connection and make sure you can hear all of the presentations. And next slide. In the middle of the screen at the bottom on your PC or Mac, you'll see participants. If you click on participants, it will pin that to the upper right of your screen, as well as chat. And if you click on chat, it will pin that to the lower right of your screen. And that's where Colin was mentioning that you'll be able to type in your questions for the presenters to answer once they're finished with their presentations. If you do not see those buttons on your screen, you probably just need to move your mouse around and then they will appear on your screen. Next slide. This slide shows where you can choose either speaker view or gallery view, and you probably won't need to worry about that too much today because we're having presenters. And so if they're sharing their screen, that's what you'll be seeing in your main screen. But otherwise, if you click speaker view, you will see the person who's speaking, and then gallery view will show you kind of the Brady Bunch view of all kinds of people who are in this session today with us. Next. And the controls are just a little bit different on an iPad. Rather than being down at the bottom, they're going to be at the top, but you can see that they're the same: the mute and unmute, the video, the participants, and the chat screen. And then over to the left side of the iPad, you can see the camera view. So if your video is not showing you, if it's faced out, those are where the controls are to go ahead and be able to control or to be able to see yourself. And I don't know that we have anybody joining us by phone, but if we do, you'll probably have to touch your screen to be able to see the different controls on the phone. Otherwise, I think that is the basics of our little Zoom tutorial, and we'll go ahead and get to the fun stuff. We're going to start with Stephanie McLean, the State Soil Health Specialist with NRCS, and she is going to, I think, do some fun demonstrations and all kinds of other stuff for us. Stephanie, whenever you're ready.
All right, good morning, everyone. All right, just want to make sure before I get running here, you can see my screen. It's on presentation view, so you can see the first slide that says focus on soil function.
Yes, we can.
Yep.
All right, then we are gonna get going here. All right, so what I'll be talking about today is again some of the basics of soil function, and I really feel that that's the building blocks for the things that Joe and Jim and everyone else will be kind of talking on later on today. So if you notice on this first slide, I talk about having healthy soil, or focusing on soil health as the goal. We have a bunch of really important soil health principles that kind of guide that goal. But what I think is some of the most important parts of thinking about or learning to build healthy soil on your farm is that you want to focus on soil function, because that's where we can really see if health is developing or not. So what do I mean when I talk about soil function? And so let's just really think about what a soil's function is. If you see the list of things that I have here, these are all functions that our soil provides to us, you know, uh, because that's what it's supposed to do. And again, that's what function means, right? The natural purpose of something, or to work or operate in a particular order. So when it comes to soil, that function is to infiltrate, store, and filter water. So a raindrop is supposed to land and infiltrate into the soil where it lands. And then that soil is supposed to hold that water until a plant needs it, and give it back to that plant. And lastly, if there's too much water in that soil profile, the soil will filter that water and release it out someplace else, like a lake, river, or stream. And as a result, that water will more than likely be filtered and supposed to be cleaner than what it was when it landed on the soil surface. Next, we think about cycling nutrients, our residues and other inputs that are added into our cropping and our soil system. Those are supposed to break down and cycled, and the nutrients that are in them are supposed to be released for the next growing crop. So on this picture here, it's a really great picture, but we have a soybean stem after harvest. They're kind of like trees. I feel like they are some pretty mean stumps left over after soybean harvest. But we already have evidence of a plant growing in that leftover stump, an annual ryegrass seedling that landed in there through a broadcast application. And that plant's roots are now growing into that soybean's roots and scavenging those nutrients that are left over after that soybean was harvested. So again, that idea of cycling nutrients. Next, we want to think about physical stability and support. Right, our soils are supposed to be a stable platform on which we farm. And then lastly, and most importantly, a habitat for soil life. So those microorganisms that live in our soil, this is their home, and they're building a stable home in where they live. And the process of them doing that, like here in this picture, those earthworms creating those channels in the soil, or the bacteria or the fungi breaking down those nutrients and exuding glues like glomalin to coat those soil aggregates, they're making a stable home. So that's their habitat, that's where they live. And when we have all of those things together, we have what we see as resiliency in our cropping system. Again, an extremely important function that we want to focus on when we look at our soils and look at our fields. When we don't have those things, we have what I like to refer to as a loss of function. And sometimes when we have a loss of function, that's where we really start to notice that we're missing those things, right? Sometimes we just take for granted that we have function until we get to this point where we don't have it. And here we see some pictures where I have a little bit of feedback right now. I'm not sure if that's just me or if everyone's hearing that.
Getting a little bit
Yeah,
too.
we are hearing that.
Mute our mics.
I just have one mic, so okay, it's better now. Good. So in this slide here, you know, things that kind of are evidence to us that we may be losing function or that our function has been degraded in the soil is when water is unable to infiltrate, and we see ponding or our residues and things left over after harvest, instead of being spread evenly across the soil surface or anchored to the soil and then starting to decompose and break down and being cycled, they get washed away and they build up in clumps in different parts of the field, and they become a waste product, and we burn them or dispose of them, or we don't see that value in what they can provide with the nutrients that are tied in those residues. If we don't have physical stability and support, right, that soil is washing off and eroding and accumulating in other areas, and try to drive in those fields when we don't have that function, right? Right after a rainfall event, you're sinking in to your lugs or deeper, or walk in those fields, and your shoe size gets 2 shoe sizes larger because that soil is sticking to you instead of staying in the field and being that stable platform. And then that habitat, right? if we don't have that habitat for soil life, those soils crust over, we reduce the oxygen exchange into those systems, and then these microbes and other animals that are aerobic creatures don't get the oxygen that they need, and they can't survive, and then they can't provide those services that we would like them to provide for us. And we lose that resiliency in our cropping system. So let's kind of just jump in right away into some of these indicators or diagnostics that I like to look at when I really try to understand the basics of soil function. You know, it's that basic question of, do I have it or do I not? And it's usually somewhere in the middle of, like, not straight up yes or no, but you're working on building function. And so the first thing that I always like to look at on a field or evaluate is whether or not we have soil cover here. And we want to really try to focus on having soil cover throughout the entire growing season. So in these series of photos here, from left to right, we're kind of starting out right after planting, early growing season, right before harvest, after harvest. And so that first picture, think about, like, if you don't have soil cover at the beginning of the growing season, right? That soil's been worked and it's bare, those residues are gone or buried. That soil is going to remain that way for the rest of the entire growing season. Whereas in that next picture, we have some cover crop there that's been terminated, a cereal rye cover crop, into a cornfield. We have that nice soil cover, and what we notice that that cover provides us is that soil is protected from extreme temperature swings. It reduces evaporation, which is, you know, keeping that moisture in that soil profile, and is so important in that August, even July timeframe, where we need a rain and we're not getting that rain. But if our soil is protected, we are reducing evaporation and we're keeping whatever moisture in that soil there. And again, the importance for soil life, reducing raindrop impact, and facilitating infiltration. So again, if you're thinking about function and if your soil is functioning or not, the first thing that you want to do is look at your field and see if you have soil cover, and evaluate how much you have out there. And is it gonna be there throughout the entire season? The next thing that we want to think about is if you don't have soil cover, do you have surface crusting? So these crusts, you know, they form after rainfall events on soils with poor aggregation. Typically, we see crusts that are occurring on fields that are overworked and left bare. So again, that idea of not having that soil cover and having a lot of disturbance in that field. Here we have some examples of a soil that doesn't have a crust on the left and a soil that does have a crust on the right. So that first picture on the left here, we're looking at a soil surface. There was some cover on that soil, and we pulled those residues away. And we, when I say we, I'm not meaning me, myself, and I, although I might be, but I'm also referring to my partner in crime, Joe Rorick, who will be speaking a little bit later today. So we go and do a lot of field visits together. We try to take a lot of really important pictures that demonstrate and exemplify function or a lack of function, and then we try to show those to people as we talk about things. So I refer to we a lot, and that usually means Joe and I. So we were out in this field, and we pulled back those residues, and right at that very surface, we see all of these nice little aggregates. They kind of, you know, oddly shaped rectangular structures and squares and slightly rounded structures. And those are soil aggregates. And so those aggregates are a conglomeration of sand, silt, and clay, right? Bound together by those soil glues that I mentioned earlier, like glomalin and other things like that. And those soil glues are exuded or by biology, like our mycorrhizal fungi and other bacteria, and coating those aggregates to help keep them stable in the soil profile. So that's what we want to see at the surface of our fields. By way of comparison, you know, the soil on the right, we have this crusted soil. So that soil was bare, and then the raindrops impacted, you know, hit that soil surface, and those particles of sand, silt, and clay were knocked loose. And then they collapsed upon themselves, and they sealed up at that very surface. So when you pick up a crust, it usually flips up, and it's somewhere between an eighth to a quarter inch thick, maybe thicker, depending on how long that crust has been building up throughout the season. But that crust is really impacting that soil's ability to infiltrate water, impacting oxygen exchange for the microbes and the plant roots in the soil. And what's really interesting about this photo is that this was actually a field that was typically cover cropped, and part of it got missed that year. And then for that whole winter and that whole spring until we were out there the next fall, that soil was bare right there. And so that crust developed just in that absence of soil cover. And when we really think about what a crust looks like, when we hold it up and look at it really close, you can see this layering here of those soil crusts, or those layers of crusting materials. So every single one of these layers would be something that occurred as a result of, say, a rain event. And then the sand settles out first, then the silt and the clays settle on top of that. And then there might have been another rainfall event, and sand or silt washed in from maybe another area, and it layers on top of each other. So this layering is very typical of what we see in a crusted soil. And again, imagine trying to really think about how difficult it is to get water through that after that crust is formed. And in so many cases, when people have a crust like that, this is a big concern for seedling emergence, and again, water infiltrating later on in the growing season. When you have that happening, it's a lot of times farmers will decide that they need to till their soils to break up that crust. But again, every time we till that soil, we're breaking down those aggregates that are reducing the chances that you have a crust. Every time you work that soil, you're more likely to have a crust develop after that. All right, so the next thing that we're going to talk about is water stable aggregates. This is another thing that you can look at in the field. The picture on the top is a soil with high aggregate stability. Remember how I talked about what those aggregates were and how they were formed, but just look at those shapes and how it holds together. And again, in the bottom, we're looking at a soil that doesn't have aggregates. There's no shape, it's really mashed together, no pore spaces, not a lot of plant roots in there. And when we think about how we want to focus on building or improving that function, is we want to really focus on managing for our water stable aggregates. We want to, again, have those aggregates have airspace and pore space between them so that water can just soak into the soil where it lands. We don't want that surface to seal up and then have it, have that water get lost or run off, or have it to even move halfway across the field to find some type of crack or earthworm channel to soak into the soil. We want that water to go in where it lands. So right now I'm actually going to stop sharing and flip to a demonstration here, and then actually depending on how long that takes, that might actually be the last thing that I do. Sheila, can you pin my video up in the corner, or do I need to actually stop the presentation? I wonder if I can spotlight that like this. Is that working?
It is on my end. Yep.
There we go.
Okay, so I just right-clicked Sheila and spotlighted this video over here, or this the other camera. I'm super impressed with my technical skills as I'm doing this. So it's like a learning process every single day. All right, so these two soils that I have here, dug these up out of the field this fall at one point in time, and they're sitting here dry because, again, it's January. But as a farmer or a landowner or a conservation professional, this is something that you can just do right in the field with the soils right there, unless you're standing in a mud puddle and it's a little bit too wet. But typically any soils are in good condition to do this. These soils were collected from about the top 2 inches of the soil surface, because that's really where we want to look at aggregate stability. We need those soils to be, water stable at the surface to allow the maximum amount of infiltration. So if you can take a look here, I'm going to tilt this down, and we're going to just I'm going to bring one of these up. And again, think about what I had said with what those aggregates look like, the shape of them, how angular they are, how strong that aggregate looks in shape. In comparison here, when we look at this one, we have some aggregates in there, but they've also kind of broken down a little bit. So they're a lot smaller, maybe down to particles of grains of sand and silt. And we're going to put them in some water now. I'm going to tip that camera back up. And we're going to put these in the water and see what happens. So one of the things that is really awesome getting to do these videos in a virtual format like that is that if you're a back row meeting attendee, right, you like to sit in the back row so you can sneak out when you're done. You don't like to, you know, be in the front and be called out by the presenter. Guess what? None of that matters anymore. You are all front row attendees here today. And so one of the things that we see right away on the video is that this one right here, again, that worked soil that we had, we see how that water cloudies up really quickly as those sediments, sand, silt, and clay particles are falling apart and showing up in the water. In comparison here, again, that water is looking pretty clean. Again, those particles of sand, silt, and clay are glued together into those aggregates. And what we're going to do is we're going to dump those out onto a plate. And if you're out in the field, you don't have to carry a plate with you. You could do this on a shovel. You could do this on the tailgate of a pickup truck, although it's kind of a mess, and you probably don't want to necessarily mess up your truck like that. But so many different places you can do this. It's just for the demo today, I like to do it on a plate so I can really have a bright background. So we're going to take those soils out of the water. Let the water kind of drip out of the bottom of them so we get rid of a lot of that free water that's in there. And then we're going to tip them onto the plate. So right away, we can see a pretty significant difference in what these soils look like, right? This soil here, the one that I was talking about with the water stable aggregates, we can still see all of those aggregates in there, right? That shape, they're still holding their shape. And what's really important to think about is the management of this soil right here. This farmer has been utilizing no-till farming practices on his farm for about 6 to 10 years, has been diligently trying to put cover crops on his fields every fall after harvest. Doesn't always happen, but he's really working hard to try to do that. And we can see how those aggregates are really holding together. You know, so that's really important for looking at soil function. Again, infiltrating water, storing water, reducing erosion, cycling nutrients more efficiently. This is a really key part of that process. Here on the other side, we're looking at a soil that those aggregates that were in that plate, they've melted. They've kind of turned into what I call like the consistency almost of like a pudding. And if we let this tip this plate up a little bit, I'm sure you're noticing that it slides around on the plate. I've decided that I like to call this skid marks. I'm getting skid marks on my plate here as this slump has kind of fallen apart and is sliding around on the plate. But this soil comes from a cropping system. Again, it's in a high disturbance cropping system. So this field is characterized by fall tillage and at least 2 passes in the spring before planting, trying to make that, quote, perfect seed bed to get that corn crop in the field and get it growing quickly. But what we see happen here is, again, we don't have water stable aggregates. So we're reducing and limiting potential infiltration of water later on in the growing season, which could in turn impact yield potential because that field isn't able to get the water it needs for the corn crop when it's growing. We're also, you know, creating potential issues with bare soils and temperature extremes, and limiting or reducing the potential for residue breakdown and release of nutrients to that growing crop. So again, like I said, this demonstration that we do here, I really think about this as a key diagnostic to understanding soil function basics in a farmer's operation, because that's the first thing that we really want to look at and understand what we have going on out there. All right, I'm gonna, let's see here, cancel the spotlight video and then see if we are, does that go right back to the PowerPoint?
It did not.
Okay.
May need to reshare.
Well, I really think that I hit on the key points that I wanted to visit with today, and I have been presenting for about 20 minutes. I think I maybe had 1 or 2 slides left that were just kind of talking about ponding and the importance that that soil organisms play in building those water stable aggregates. So actually, I think that now would be a great time to transition over to Joe and have him kind of build on these concepts a little bit more with soil health principles, and then management practices that can be done on the farm to increase and improve soil function.
Okay, Stephanie, that sounds great. One other thing I'm going to take care of quickly before I let Joe in is some poll questions. I had intended to do this after the brief Zoom instruction once all of you knew where all the buttons were, but we'll go ahead and do that now just before we let Joe speak. And I'm going to launch some poll questions, which you'll see on your screen. And there are just 3 questions. So if you could take just, 30, 40 seconds to kind of go through these and provide your answers, we would appreciate it. Seeing a good amount of people who have at least tried cover crops, as well as practices to reduce erosion. This is great. We'll go just a few more seconds here to give you a chance to get through these. See, answers are still coming in. Okay, I don't want to take up any more of your time. I'm going to end the poll and go ahead and let Joe get started with his presentation about practices.
Perfect. Thanks, Sheila.
Let's show the results here really quickly, but we can go through these at the end as well. Go ahead, Joe. Thank you.
So we've got a good mix of folks here today. That's great to see. So again, hi everybody. My name is Joe Rorick. I'm the agronomist for CCSI. I'm with Purdue Extension, and we're going to talk a little bit and build a little more on some of the basics underlying those functions that Stephanie talked about, and we're going to do that through the framework of our soil health principles, right? So we're going to look at some examples here. We've often got pretty wet springs. So how do our systems function in wet conditions? And Stephanie showed you some of how to look for some of those functions. But this is what that looks like from the road edge, right? So on the left, you can see that water running off. In both these pictures, there's water control structures here. So, this may be a low point in the field. We know that water is going to run to that, but the way that we manage our fields affects that water as it runs off, right? And as that water runs off, sometimes it carries some of our fields with it. So you can see that on the left. You can see the topsoil, that cloudy water. You can imagine that anything that's bound to that topsoil is then also in that same water. That field on the right with no-till and cover crops, right, that has more of those functions that Stephanie talked about, you can see how much clearer that water is. So that's a little bit what it's like when it's too wet. What about when it's too dry? Well, if that water all runs off and carries our topsoil with it, and that soil crusts up, and we don't get any or enough infiltration, if we have a soil that can't hold water, then, like you can see in the conventional tillage here, if it gets too dry, that corn rolls, that soil crusts up, dries out, cracks. That soil is not able to hold water. But on the right, where that soil is covered, you can barely even see that soil surface. We had a pretty clear yield difference in that instance, and you can see the corn's taller and it looks better, and it's got a much better chance, if we were to get a later rain there, to be able to take advantage of that and recover better. And one more example, not to give you the whole Goldilocks and the 3 weather conditions thing here, because it's not, this is back to wet again, right? But often we hear about, well, you know, I don't need any of this. I don't have soil erosion. My fields are all flat. Okay, well, that's fine. But even if your fields are flat, you still have soil erosion. That's if you have bare soil, it happens. But you still get ponding too, right? You still get water movement because that water won't sit on that field. That water will move, and it'll move to, the lowest point in the field, or it'll move off the field, and it'll carry your topsoil with it. And it'll carry all the things that are bound to that topsoil. It'll carry all the things that are floating in that topsoil. So if you do a little bit of tillage and loosen up all your residues, it'll float away all your residues down to wherever the lowest point is in that field. And then you got to go through and manage them when they're 3 feet deep. So, these are some examples of what we're talking about when we're looking for soil health. So, you guys all know that soils have chemical, physical, and biological properties, right? And we can improve soil health by influencing these properties, right? So through the physical, we can do less disturbance. Through the chemical, we can make sure our pH is correct. We can make sure that we're not doing things that are going to throw off and create a chemical imbalance or a bad chemical situation in our fields. And through the biological, we can add, or we can grow organic matter and influence that soil biology by feeding it, right? And then, of course, organic matter is a key player in all of these different properties of our soils. And Stephanie really showed you these, so I'm not going to spend a lot of time on these, right? But we want soils that can absorb water. We want soils that can retain water, and not like we saw in some of those pictures where it just sits on top, right? We want soils that have adequate aeration in addition to being able to retain water, right? You don't want to see those platy structures like Stephanie showed. You don't want to see that crusting. You just want good rooting and a good condition for plants to grow in, right? Because we're trying to grow a crop, we're trying to run businesses. So we have these soil health principles that we can use to guide our management decisions. And it's important to remember that even if you can't do all of these all the time, the more of these that you can do, the more often, the farther along you'll get with your soil health journey. So we want to minimize disturbance wherever we can. We want to maximize soil cover. We want to maximize biodiversity as much as possible. And we want to maximize living roots and provide a continuous living root throughout as much of the year as possible. Minimizing disturbance is often thought of as a physical disturbance, and that's usually what we are the most concerned with. There can also be chemical and biological disturbances, right? If you're making multiple unnecessary insecticide passes or fungicide passes, that can be a chemical disturbance. If you're making a really extremely heavy manure application, that can be a biological disturbance, right? But generally we think of disturbance as physical disturbances, and not all equipment that engages the ground is created equal, right? So here in this photo, you can see on the left, you've got non-disturbed moving up in grades of disturbance from a low disturbance drill through a high disturbance drill, and then some of our tillage equipment. But it's important to remember that not all disturbance is created equal, right? It's still possible to disturb that soil in an improper way, right? So if you're going to do tillage, make sure conditions are right. In the same way that if you're going to plant, you want to plant in as good a conditions as possible. If you're going to do tillage, you want to make sure you're doing tillage in as good a conditions as possible, and making sure that you understand why you're doing that tillage and have a good reason why you're doing that tillage. So these pictures that we're looking at here are of a vertical tillage tool. And I don't know the situation, what exactly happened here, but this is sort of using a cover crop as a diagnostic tool. You can see on that picture on the left, that radish tuber goes down about 2 inches. And then you can see on the soil knife there, that orange handled job there, that the soil structure changes right there at that sort of 2-inch depth. And that matches up with that sort of kink in that tuber where that root was trying to grow down. It hit a limiting layer and had to grow over before it could continue its journey downward. We moved a little farther over in the field and dug some more. And here on the picture on the right, you can see that root growing horizontally across that layer, right? Because that root, in addition, that root could not grow down into the soil because it was obstructed, right? So you want to look for limiting layers out in your fields. So do we have a restricting layer here? Yeah, yes, we do. And that was caused by, even though it was it was a vertical tillage tool, right? Which is a sort of a minimum tillage tool we would think of. It maybe, something happened. It wasn't done properly. Conditions weren't quite fit, and we still got a compaction layer there. And Dr. Camberado will talk a little bit more about this sort of thing here, but I just wanted to show this graph quick about if you're going to reduce tillage, you need to understand how that system is going to react, right? So in this graph, we're looking at springtime warm up. So the soils warm up, the soil microbes go crazy. You get this big spike. This is often when spring tillage is done as well. You break apart those aggregates, you free up all the carbon and sugars and things that are in them. And the soil microbes take advantage of that, and you get this spike of activity. And this is also generally a spike in a release of available nutrients. Although you look at the timing, and there aren't necessarily big enough plants out there to take advantage of that release of nutrients at that time, that sort of May timeframe. When you don't till the soil, when you leave those aggregates intact, you don't get that spike, that release of nutrients, which is often why we talk about starter fertilizer and how important that is. But you get this more kind of slower, continuous release throughout the season, right? So that's a little more on what you would want, because you're not only growing corn right here in this May timeframe, you're growing corn the whole year, right? You're growing soybeans the whole year. So you want those plants to be being fed throughout that year. So then we want to maximize soil cover. And Stephanie talked a lot about soil cover, but that cover is protection. That cover is protection for your soil. That cover is protection for the field. It helps to protect from raindrop impacts. It helps to hold your soil together and enable you to get out there in wet harvest conditions. It protects from evaporation, lots of things. We have active soil cover and we have passive soil cover. Your residues are kind of a passive blanket. They're out there and they're protecting. But like with our cover crops that we often recommend, those cover crops have top growth that are protecting the soil and have other benefits. You can see that clover bloom in there. That's great for the pollinators. And not even just the pollinators, there's lots of insects, beneficial insects that take advantage of a free nectar source. But then those roots grow in the soil and they also then feed that soil. And you can see here, not all cover is created equal either, right? So this picture on the left, this is a field down in the southeast part of the state. And you can see that soybean residue is a good no-till field and had been for quite a few years at this point. But they planted up and down that slope, which is the way we had to lay out the research plots. And even though there is cover out there, those soybean residues weren't able to provide enough. And we had to do some disturbance with the planter, right? You have to, you need to be able to plant. But because of that physical disturbance and because of that lack of cover, we got some erosion here, and we got erosion right in that most critical zone. It washed out the seed trenches. So the seed got washed out, the starter fertilizer, the in-furrow got washed out. and parts of this field in a better picture, and I cropped it out of this one. You can see some of that seed laying down here at the bottom of the hill where it got washed out of there. But on the right, where we have that cereal rye residue, that same planter ran through this field, but we didn't get that erosion, right? So we had to increase our amount of cover in order to protect that field, right? So then we want to maximize biodiversity. We need to feed the herd in our soils, right? This is a little bit of an older graphic, but I like it because it's easy for me to understand, right? So in an acre of healthy soil, there's 2 cows worth of microorganisms living in that soil, and estimates are even more than that now, quite a bit more in the order of elephants. But then you have to be about a biologist to decide if, well, it's an Asian elephant or an African elephant or some other kind of elephant. And is that the ones I see at the zoo or like the circus when I was little? Or I don't, right? I can picture a cow much easier. But the point is, it's a lot and you have to feed them. And one of the ways we do that is by getting cover crops into the system. And I know this graphic is hard to read, but the idea, what you're seeing here is we're not trying to look at the specific species of these cover crops, but sort of the general shape and size and the shape and size of the rooting structures. This graphic is available for download from our website, ccsin.org. But you can see on the left, you've got some of our grass species cover crops that have a really big mass of roots. And then you move over into, some of the radishes and things with some deeper roots. And we'll look at this again. But, the idea is you can get biodiversity into your system by adding different plants. And by adding different plants during times of the year when you're not growing a crop, or even if you are growing a crop, if maybe you're interseeding or something, you're helping to provide continuous living roots, which brings us to our 4th principle, which is just that, right? You want to maximize the amount of roots that are in your system because you're feeding that soil livestock. Those plants are photosynthesizing, they're pulling carbon out of the air, they're taking in sunlight that's hitting them, and they're making sugars. And they're pumping some of those sugars back into the soil to feed those microorganisms that are working at that soil and helping to cycle nutrients in your soil. So then once those roots die, and here's a close-up of part of that graphic we just saw, those roots are in there feeding that soil when they're alive, but then when those roots die, those channels are still there. And down to 60 or so inches, this graphic goes, you have open channels once that root decays that has more available nutrients in it, that has a straight open shot right to the surface down to 60 inches deep. If you do tillage at 6 or 8 inches, you have cut off the connectivity of those pores and lost a lot of the function there. And if you're doing tillage, you're also breaking up that soil, but those roots can help to build that soil back up, right? So like Stephanie talked about, actively managing water stable aggregates. These are that same demonstration she showed you, that same test that she showed you. And this is even in a sandy loam soil where we don't often, sandy soils have good infiltration, right? But you can see on that soil on the left, it has poor water aggregate stability, so it crusted up. On the right, we have a little bit better aggregate stability, and these both were cover cropped over the winter. One was tilled in the spring, one was left cover cropped with the residues in place. This was just over the course of a summer that those aggregates on the left broke down and that soil crusted up. And not to just focus on corn and soybeans, but this has big implications for all of our crops. Here you can see pumpkins. By having that soil cover in place, by having those water stable aggregates, you can reduce the amount of soil splash you get and get a cleaner product. So that pumpkin on the left needs wiped off before it can go on the truck, right? That pumpkin on the right, it's done, it's ready. That can get picked and put right on the truck or right on the porch, whatever you're doing with it. So we have our soil health principles that we can use to guide our management decisions. We want to minimize disturbance, physical, chemical, and biological. We want to maximize soil cover. We want to maximize biodiversity, and we want to provide a continuous living root throughout as often of the year as possible. And let's look at just one more quick example. Here we have a field. This is from our infield advantage program. A lot of you might be familiar with it. But what's that dark stripe on the field here? You might be thinking, well, is it soil types? Well, is it, what is it? What could that be? Is it, you know, they forget to shut off the nitrogen bar, they overlap a row? What happened there? Well, it's not soil types. If we overlay the map on it, it's right there at the edge, right? And you know, right now some of you are going, it's a fence row, it's a fence row, right? And well, that's exactly what it is, right? And if you think about it, that fence row has our soil health principles sort of inadvertently applied to it, right? It's got minimized disturbance, it's got maximized cover, it has living roots in it, right? It has those principles that have been applied to it. And you guys have all seen your yield monitors when you go over an old fence row or an old hog lot or an old pasture piece, right? You have seen these, you know that dark green taller corn is good. You know that light green corn is bad. So what happens if we can apply these principles beyond that fence row across the whole field? How much better, how much more resilient our cropping systems can be with that. So thank you guys for your time. Here's my contact information. You can get a hold of me. Jim, that's all I have. So I'll stop sharing if you want to start bringing your slides up. So up next, you've got Dr. Jim Cambarato, who's here at Purdue. He's one of our extension specialists here. And we're very excited to have you here, Jim. So
right.
Thanks.
Thanks, Joe. I suppose you can see my slides okay? All right, great. So I'll put my email in the chat when I get through talking, in case you have any questions later in the day or tomorrow, etc. I'm going to just talk about two topics, and if we only have time for one, then I'll stop at one. But my responsibilities are in soil fertility, and I thought we could talk a little bit about pH. And if we get done with that, we could talk about using urea-based nitrogen fertilizers. And I chose those two topics because in high residue, minimal disturbance systems, they can be a little different than in conventionally tilled systems. So we may need to think about them a little differently, maybe take soil samples a little differently, and then make decisions a little differently. So we'll talk about pH first, and you see here the scale of pH from 0 to 13. 7 indicates a neutral pH. Less than 7 is acid, and above 7 is basic. And you'll note that humans are pretty tolerant to a wide range of pHs. So we eat lemons and drink orange juice and eat tomatoes and drink beer, and those have a very acid pH of 2.5 to 2 to 3.5. And then we can also tolerate some things that have pHs above 8. So humans, we have membranes and we have the biology to tolerate pretty wide range of pH. In soil, you'll see pHs range from as little as 3, where we have the oxidation of sulfur to sulfuric acid in some soils, and as high as 9.5, where we have soils dominated by sodium carbonate. That's generally the widest range, and in most cases you'll see soil vary between 4.2 and 8.2. However, the desired pH that we maintain for growing most crops is somewhere between in the high 5s to about 7 or slightly above. So plants have a much narrower tolerance to pH than we do. And moving the pH into that range is beneficial not only to the plants, but also to the microorganisms. So microbes, as we know, are very adaptable. So they can tolerate low pHs and high pHs, and some of them thrive at low pH and high pH, but the great majority of bacteria, actinomycetes, and protozoa, the great majority of them have optima around neutral pH or slightly alkaline. So right at the top of the range in pH that we're managing soil for plants. Fungi are different. Fungi can operate at lower pHs, and the average optimum is around a pH of 5. So they thrive better at those low pHs. So we're talking about this not only because it affects plants, but because it affects those microorganisms. And Stephanie and Joe talked about the importance of residues. And some aspect of residues is they need to remain intact when they're on the soil surface to protect the surface from raindrops. And but they also need to decompose to produce soil organic matter or humus. And the microbes are responsible for that decomposition. And when the residues are broken down as far as those organisms can break them down, then that's when the humus can associate with soil particles and become stable in the soil. And that would be your long-term increases in soil organic matter and the organic matter that's helping to glue together those aggregates. So we want a good pH for those microorganisms to actively have a optimum activity so that they can create organic matter. During the process of breaking down residues, the organisms will eventually release some of the nutrients that are structural in those residues, and that's nitrogen, phosphorus, and sulfur. And so we talk about nitrogen mineralization and some of that providing to the nutrition of the crop. And we also see phosphorus and sulfur being released or mineralized from those residues. Organic matter is also important for the availability of micronutrients like zinc, manganese, and copper. Those micronutrients aren't structural to the organic matter, but as the microbes decompose the organic matter, then they'll release those micronutrients, and sometimes they're still attached to small organic molecules, and it helps maintain their activity and enhances their availability to the crop. So we're interested in maintaining a good pH to optimize the activity of microorganisms to produce organic matter and release some nutrients to plants. pH is important for plants for a couple reasons, and the primary reason is it promotes a good environment for roots to thrive. And we see here a healthy corn root system and a healthy soybean root system that's nodulated with bacteria. And those are examples of roots that are in a good environment, a good pH environment, to be healthy and thrive. When the pH becomes too low, it creates a condition that can damage roots and inhibit nodulation of legumes. Most of those effects are due to the availability of aluminum, which is a structural component of soils. So at low pH, the aluminum becomes more available, and it actually kills the growing point of roots and results in a shortened, thickened, inefficient root system. It also inhibits the bacteria, that rhizobia, that infect legume plants. And also with low pH, we often see low calcium, which also affects the rhizobia activity. And so legumes will fix less nitrogen due to low pH. pH is also important for the availability of some nutrients, and this is what we most often think about, and it can be important, but really the impacts on roots are the primary effect. This is kind of a secondary effect. And so phosphorus availability is optimized in the range of pHs we manage for crops, so somewhere in the 6-ish to 7 range, and availability decreases at lower pH and higher pH because the phosphorus interacts with soil components more when you get outside that range that we're shooting for. And then micronutrient availability decreases considerably with high pH. And we usually worry about manganese and zinc in most cases, and sometimes copper in organic soils. Micronutrient availability is not like phosphorus, where it tails off at low pH and high pH. Micronutrients become much more available at low pH, and they can actually become toxic if the pH gets too low, and they're prevalent in the soil. So pH affects nutrient availability from a chemical standpoint, and we're aiming for that 6 to 7 range to maximize that availability. All right, so there's several factors that create acidity. So we have carbon dioxide that's dissolved in rainfall and in the soil water, and that generates acidity a little bit, and that causes our soils to be acid. In the past, when we had more air pollution, nitrogen and sulfur in the atmosphere caused quite a bit of acidity, and that contributed to soil acidity. The loss of bases, basic cations, so calcium, magnesium, and potassium, creates acidity. And some of that occurs with the leaching of those nutrients below the root zone, or the removal of those nutrients in grain in plant material. And so if we're just harvesting grain, those losses and the acidity created is relatively minor. But if we're taking an entire forage crop off of a field, then we generate quite a bit of acidity just by removing calcium, magnesium, and potassium from the field. So all of those things contribute to acidity, but in most cases, the primary or the factor that has the greatest effect, creates the greatest acidity, is nitrogen. And so with nitrogen fertilizer, you're concerned about, or source, rate, and placement will affect how much acidity is produced and where it's produced. So source, there's variation among the sources in how much acidity is produced. Primarily, we use urea, liquid nitrogen, which is half urea and half ammonium nitrate, and anhydrous ammonia. In actuality, those three have very similar potential to create acidity, and it's usually expressed as in terms of calcium carbonate. So a pound of nitrogen will create enough acidity to neutralize 2 pounds of limestone. Ammonium sulfate, diammonium phosphate, and monoammonium phosphate, create more acidity, 2 to 3 times more acidity. So they will consume, the acidity they produce will consume 4 to 6 pounds of calcium carbonate or limestone. And typically we add those ammonium sulfate and the ammoniated phosphoruses to provide sulfur and phosphorus. So we don't add them in huge quantities, which is good because we would be creating a lot of acidity if we were using those to provide all of our nitrogen. Rates obviously important because the more you apply, the more acidity you generate. And one aspect of acidity that arises from nitrogen is the leaching of nitrate. So if you add more than the plant can use, and then you lose that nitrate below the root zone, it's creating this or leaving behind acidity. And then placement is important because wherever you put that nitrogen is where that acidity arises. And the movement of acidity in soil is really pretty slow. And so you can have localized pH effects. It doesn't equalize itself across the soil profile. It stays where it's, it moves out very slowly from where it's produced. And I'll show you a slide later to show how concentrated those effects can be. So we'll start here with a slide. So this is from the agronomy farm on a prairie soil here near Purdue. And they had implemented some tillage practices for about 30 years. They had a bottom plow, chisel, ridge till, and no-till. And so the disturbance is greatest at the top of this figure and least at the bottom. And then they took samples from 0 to 4 inches and 4 to 8 inches. And you see where you get good mixing with plowing, that the pH was equivalent in the surface and this top 4 inches and then the next 4 inches. But as you minimize that disturbance, you do much less mixing, of course. The pH of the 4 to 8 inch zone can be considerably less than the 0 to 4 inch zone. So lime is applied on the soil surface, and for most of these years, for all of these years, they injected nitrogen below the soil surface, either anhydrous ammonia or liquid nitrogen. So they generated acidity below the soil surface, but they were needed to apply the lime to the soil surface. And the lime effect moves very slowly into the soil. So you end up with a good pH in the surface, but an inadequate pH in the subsurface. In this same experiment, and this comes from some earlier samples, only 20 years of no-till continuous corn, They were pretty careful to keep the rows in exactly the same place and inject the nitrogen in the same place. And this was all anhydrous ammonia. And you see on this slide, on the vertical is depth from the soil surface down to actually 10 inches. The numbers represent the middle of the layer they sampled. So they sampled every 2 inches in the vertical and every 3 inches in the horizontal. And the zeros on the horizontal represent where the corn was planted. And the mid row is at 15 inches. And that's where the nitrogen was injected. The blue colors represent very acid pHs ranging from 4.5 to 5.5. The greens represent 6 pHs in the low 6s, and the yellows and the oranges from 6.5 to 7. So you see in the middle where they injected this nitrogen for 20 years, they actually have pHs as low as 4.5. And that zone, injection zone, the acidity created in that injection zone has grown to occupy that mid row almost to the surface of the soil and down to 10 inches. And so that's a really unsuitable environment for roots to grow. And that's where you're putting your nitrogen. And the microbes in that zone are going to be doing very poorly as well. So in the systems where we don't do a lot of disturbance, we're going to layer or concentrate the effects of acidity in different places. And if we take a generalized soil sample, we're not going to see this because we're going to be mixing soil with a pH of 6.5 and 7 with soil that has a pH of 4.5 and 5. And after we mix it together, we're going to have a pH of 5.8 or 6.2 or something kind of in the middle. Well, some of you, and even me, before I learned about this, I'd say, well, what about if we use legumes to create our nitrogen? Well, it turns out the process of fixing nitrogen from the air also generates acidity. And you have a net generation of acidity when you remove either the grain from the field or the entire forage. If you remove the forage, you create more acidity than if you just remove the grain. And say for a soybean crop, they can generate anywhere from the acidity to neutralize 250 to over 500 pounds of calcium carbonate in a single season. So they're almost as acid, create as much acidity as fertilizing corn with nitrogen. Now it's interesting, of course, if you don't harvest the legume from the field, if you turn it in as a green manure, it generally doesn't create acidity in that year. Of course, when the next crop takes it up, it will. But it has a neutral effect on the soil overall, but it creates subsoil acidity and increases the pH or creates space at the surface where the residues are deposited. So even with a green manure legume, even though we're not creating a net increase in acidity, we're actually making the subsoil more acid while we lime the surface with the manure, the green manure. So I think one of the things to take a look at is, based on what you're doing, occasionally in some fields, take soil samples from different depths and different positions away from the row. If you use controlled traffic or you continue to plant on the same pattern. If you don't plant on the same pattern, you're mostly interested in the surface versus the subsurface. If we create acidity at the surface, it's great. We put our lime on, it takes care of it. If we create acidity below the surface, we really need to sample frequently and apply lime on a regular basis to give that lime time to move down into the soil and maintain soil pH before it gets too low. If you could perch an inch of water on an acre of soil, you could only dissolve 3 pounds of lime in that 27,000 gallons of water. Lime is very insoluble, and so it needs quite a bit of moisture to react and move into the soil. And estimates are in a silt loam or silty clay loam that pH effect only moves about 1 inch per year. So that's why we want to keep up. We want to recognize what our pH is from 4 to 8 inches or wherever we're injecting our nitrogen, and keep that nitrogen application to the surface on a frequent basis so that it has time to move down before that pH can get into the low 5s or below. With that, I think I've come to the end. We won't talk about nitrogen today, but hopefully we learned something about pH, and we're thinking about checking our fields to see if we have any layering or localization of pH effects that we might think about correcting before they get out of hand and affect our microbial activity and our plant health. So with that, I guess I'll be turning it over to Ed Ferris.
Yes, too, and just quickly, Jim, thank you for your presentation. That was fantastic information. We had originally scheduled at this point to have a kind of 10-minute Q&A session. If anybody wanted to provide questions specific to any of the 3 presenters, or if they had a general question that could be kind of attacked by each of the presenters themselves, but doesn't seem that anyone has contributed any questions to the chat. So just to familiarize everybody, the chat again is at the bottom of your screen. If you want to ask a question, feel free to do so. I see also that each of the 3 presenters so far have provided their emails. So if you do have a question you want to ask later on or think on later down the line, their emails are in the chat for you to reference. So I guess if we don't have any questions, I will open it up to you 3 briefly before we go back to Ed. Just here, if you, Stephanie, or Joe, or Jim have any additional comments or anything else you would like to add before moving on to Ed, that's fine. If not, yeah, we can pass it off to Ed too. So I'll leave it open to you 3 or anybody else in the chat to ask a question just here briefly before we move on.
I was going to bring something up, and actually was a question I wanted to ask Jim about the discussion on nutrient stratification. Jim, one of the things I was recently reading some articles on nutrient stratification and no-till cropping systems, and that discussion on looking at that. Even in tillage system, stratification actually occurs as well. And that discussion always is that it's a big concern and that it's a problem. Yet what we're starting to find out is that it actually just happens naturally and normally, and that we just, if we're looking at converting to no-till, that we need to make sure that we're managing that no-till properly, so that, again, those soluble nutrients that probably sit closer in the top of the soil, that soil is protected, that we don't have erosion and we don't lose those soluble nutrients. But a lot of our feeder roots that we get from our plants are getting those nutrients in the top of the soil profile, right? We're not, those plant roots down way deep in the soil surface get some nutrients, but they're mainly looking at water, right? So I guess I just wanted to have a deeper discussion on stratification.
Yeah, so you're right. In most environments, and especially ours, where we generally have more rainfall than, say, Iowa, Nebraska, et cetera, that stratification of nutrients has not shown to be a problem for plants acquiring those nutrients, in part because the no-till systems maintain more moisture in the surface, and they have more a higher percentage of their roots closer to the surface where those high nutrients are. So we generally don't have concern with nutrient availability and access with stratification of phosphorus and potassium. So the deep roots are generally, in most soils, yes, they're taking up water and nitrogen and sulfur. And you'll find in many of our soils, the phosphorus and potassium, as you go deeper in the soil, diminishes quite a bit, particularly phosphorus. And so those nutrients aren't there for taking up. We generally get plenty of calcium and magnesium and micronutrients from the surface, but nitrogen and sulfur can, the deeper roots can take up quite a bit of nitrogen and sulfur, because it's going to move with water down to those depths. So that they become important for those nutrients.
Thank you. Joe, is there anything else that we want to bring up from our discussions on the principles or other things like that before we move on? Or is there anything that you're thinking about wanting to add?
I guess I have another question for Jim while I have him here. Jim, you've done some work with sulfur as well. How important are you seeing the addition of sulfur to a fertility program?
So we started in 2017 and doing experiments throughout the state. And I think we're up to almost 30, and 40% of them have responded positively to sulfur fertilization. We're not able to really predict very confidently where those deficiencies will occur yet, and so we're still working on that. But low organic matter, sandy soils, which we've always known to be prone to sulfur deficiency, would be, more likely to show response to sulfur fertilization. And soils that have 3% organic matter and silty clay loam textures. So, and those really surprised us. And in some areas of the field, they were 40 bushels to the acre. So, so that's something to keep an eye on. Where you use manure, you probably don't need to worry about it. I wonder about, some of the cover crop systems. I could see that there'd be positive effects of that, and in some cases it could be negative, but that'd be something to keep an eye on.
Sure. I mean, if sulfur is as mobile as nitrogen, and we talk about cover crops being extremely important for holding nitrogen in a field, sulfur should track pretty well with that as in addition. So
Yeah.
that would make sense, but that would certainly be interesting to look at.
Yeah, and in a little bit of work we did with wheat, we found that the residues, the microbes fixed the nitrogen, took it out of the soil solution and restricted it from the plant, but it actually did not do that with the sulfur. So I think, there's still possible they would fix sulfur, but I don't think it's likely in most of our cropping systems. There'll be a net release.
Very good. Thank you.
Great, thank you. So if there aren't any questions from those in attendance, we'll go ahead and turn it over to Ed Ferris with Purdue Extension, who will be providing us with a dicamba and regulatory update. And then we will have a second set of poll questions. And I just think it might be best to just present those after Ed's presentation, if that's okay with you, Sheila, and then we can kind of run through those. So with that being said, I'll turn it over to Ed. If you want to go ahead and share your presentation, the floor is yours.
Okay, can everybody see my screen, the slides? Are we good, Colin?
Yep, we're good, Ed.
Okay, thanks, Sheila. Okay, so I did want to share an update on dicamba and pesticide records. Many of you do have private applicator licenses that are viewing today, and I emailed you the CVent link to go in and register to obtain those, to pay for those credits. There is also there are also credits approved for commercial category 1, 14, and registered technician. There are 2 CCHs approved. Several of you have already emailed me your license number if you are a commercial applicator. If you are a commercial applicator and you have not emailed me your license number, I would need you to do that after we're done here today, so I can report that you participated in this workshop to the state chemist. And again, there's 2 CCHs available for categories 1, 14, and registered technician through your participation today. So we'll go ahead, and I just wanted to start by talking about the state chemist website. For dicamba, if you go to the list of available resources, this frequently asked questions were updated January 21st, 2021. So this is hot off the presses, as they say. And as you can see, on October 27th, the U.S. Environmental Protection Agency announced that registrations for these dicamba herbicides were extended through 2025. And I'm just going to share some highlights with you from these frequently asked questions. I have participated in recent workshops with Joe Bekowitz, I know spoke I believe it was last week in a workshop, and he highlighted some of these things. And so there's lots of information in this FA frequently asked questions sheet. And I encourage anyone that is thinking of using or planning to use or has previously used dicamba and to go ahead and take a look at this just to get you up to speed. Indiana is pursuing a June 20th application cutoff date for 2021 season. Unlike 2020, this is going to apply to more dicamba herbicide products. And again, it mentions this is different than the federal cutoff date of June 30th. Purpose of this difference with the federal cutoff date is to address the unacceptably high number of off-target movement incidents resulting in the adverse effects with the later season applications. Other things that are I'll highlight from is that anyone mixing, loading, applying, or cleaning dicamba application equipment must become certified and licensed private applicator or commercial applicator. The only thing that they will allow is workers that that are not certified. They can be involved in transportation of unopened containers that were mixed, by somebody certified. So the next thing here is to say that most of you have that have worked with dicamba in the past know about how the training works. That's originally this was all done through the Office of Indiana State Chemist, and Purdue Extension was involved in providing this training. And this is no longer the case. It's going to be the same. You have to go to the registrants, and it can be in person or virtual group training, or maybe self-directed online. And the Office of Indiana State Chemist recommends that you go ahead and visit their websites or contact them directly for details on how to get this annual training completed. This is something new in 2021. The applicator records must include the identity and receipt of for the label requiring pH buffering adjuvant and drift reduction adjuvant mixed in every tank mix. So there is a Purdue pesticide programs. Many of you have received this handout when we've had face-to-face training, and it's updated every year. And I strongly encourage you to go and it's not the most readily available thing right now, but I think in the next couple weeks you'll see it available on the it should be in the Purdue Ed Store website along with the State Chemist website. If you're having trouble finding this record sheet, feel free to email me and I will send that to you. But it does satisfy, all the information that you need for dicamba record keeping in Indiana. Another thing that's changed is the buffer requirements, and what we have, there's a standard 110-foot downwind buffer that y'all remember, and that's actually increased to 240 feet. If you have the crop which non-dicamba soybeans, if they're they're grown right next to where you have the dicamba soybeans, then you have to have this downwind buffer. If the wind is, you have to follow the label, and always maintain that 240 feet between the last treated row and the nearest downwind field in the direction the wind is blowing. So this is the thing that they mentioned when you hear the state chemist guys, talk about what is the one thing that seems to be that they'll assess a fine right off the bat. And this, if you cannot show that, if this is the case, if you clearly didn't follow the label by using this product when the wind was blowing downwind towards a sensitive crop, and you did not follow this buffer, that's going to institute a fine. And I believe those fines can go up to $1,000 now. So it's critical to check the wind. And there's many tools available that you can use. I've had guys have apps on their phones, and if you have something, even while we're in this discussion, type it in the chat if there's something that you use that really helps you with this area, because I think that there's many things that have come along in the last few years to help to protect you in this area, and know what the winds are and how to report that and document it, how to go ahead and checking the sensitive crops and on the website that's available there. And the other thing that seems to be expanding here, well, it is expanding, there's more counties that are involved with this, is if there's a protected endangered species. So you can see now, I think a couple of years ago there was only a couple counties mentioned, and now there's 6 counties that there. So this is something that is changing. That this 57 additional buffer is required when you have those endangered species in these counties. So that's something to keep your. I don't know if anybody that we have people from many counties here today, so I just wanted to highlight that because that may be one of the counties that you live in. And these are just some private applicator record requirements. You can see that to keep the records for 2 years, want to make sure that I highlighted this, recorded it with 30 days of application. There's no specific form when it's just when you're talking about restricted use pesticides. Obviously, I mentioned the dicamba form. That's going to help you tremendously if you're using that product. But just as long as you do record information about when you applied, and this is the required information: location, of course your name and permit number, or whoever, if you're working with another somebody's that came onto your property and is a certified applicator, and are you working with a company or something, that they would have that documentation for you. Date of application, crop, the pest that your pesticide, whether that's an insecticide or if it's a herbicide, just make sure you identify what it is that you're using it for, and the rate, the amount used, the brand name, formulation, manufacturer, all these things are necessary to have in your reports for the 2 years. And I know there's a lot of you here that are category 14 private applicators and commercial applicators. And so just keeping those records of the manure applications, and then your commercial applicators, the inorganic fertilizer manure applications, that keep them for 2 years. And again, commercial companies can maintain them for their customers as well. One thing that is mentioned, if you've heard Fred Whitford has talked about record keeping, and if a licensed healthcare professional does need to review that for emergency situations, they do have access to know what you have been spraying on your property. And also, the Indiana State Chemist does do spot checks on occasion, and just to have those records available to them if they do request is critical to have. I mean, obviously they're not they have limited, and things have changed with them with the COVID-19 situation. So they've changed some of their how they investigate if they have a drift complaint. It's not always that they make a site visit in the cases because there's so many cases that have come along with dicamba. So they do have a procedure that they follow, and so but it is important that you do have those records ready to roll. I'm going to stop at this point and just say, does anybody have questions that really for me, myself, or any of the speakers, if you feel free to type in your questions, and because we've kind of moved through things a little more quickly than we anticipated, so we are getting close to the end here, and I know Sheila does have a few questions that we'd like for you to answer for us. And so whenever Sheila's ready, she can go ahead and post those. But at the same time, this is a good opportunity to, if there's some burning questions you have, feel free to type them in the chat. Are they able to unmute too, Sheila? Is that possible?
Yes, you should
Okay.
all have the ability to unmute yourself. If you'd like to go ahead and do that and ask your questions that way would be fine.
We welcome that, because there's a lot of I know surely there's some things that people might be wanting to know after hearing all these presentations. And
if you're on a phone, *6 will unmute yourself. And again, if you're on your computer, it should be over there in the lower left corner. Give you just a few more seconds on the poll questions.
Well, Ed, it doesn't look like anybody's going to admit that they didn't learn anything. So that's good. We can give them all their credit.
That's good.
Not that I have anything to do with that whatsoever.
Okay.
Here are your
As far
results.
as giving the credit, but
Okay. Again, if you want to unmute and ask anything, we do have a little extra time here today, so.
Don't be shy.
And I guess we'll just open that up to any of the presenters, or any Colin or Sheila or anybody else. Is there something else that we've forgotten today that we need to cover, or just to highlight?
well, I would like to hear from from our audience. So it looked like we had a pretty good mix of people that are doing some no-till, some min-till, some cover crops. So what sort of challenges are you guys seeing with those?
Yeah, I've
And-
got a question.
Yeah.
I farm with a couple, three brothers, and we've got a conventional corn planter. And to do these practices that you talk about, I think it's a great way to go. But because of some farm debt that we have and such, it's hard for us to go out and buy a different planter. Normally when you no-till corn, they usually put row starter down. So, and if I went out and bought one without telling them, good chance I'd have to put a stake on my eye the next couple days. So what practices can I use with a conventional planter at this point to help with my soil health? Can you put cover crops on in the fall of the year after your crop comes off, and then till it in the spring? Is there any advantage to that?
Yeah. So, and Stephanie, feel free to jump in here if we still got you. Nobody really sells a good no-till planter anyway. That's why so many companies exist, to get your planter set up better. But that's absolutely can be a challenge. So I appreciate that. But there are still advantages to using cover crops and still needing to do a little bit of tillage, and even just moving your tillage passes from the fall to the spring has soil health benefits, right? By leaving that soil covered over the winter, you're still going to protect it a good deal, just by leaving those crop residues in place. Not the full benefit you would get with having a cover crop growing all winter, but there are some good winter kill cover crop options. So that's why we talk about like oats and radishes. Those will winter kill when the temperature gets cold enough. And then there won't be that much residue there in the spring. There will be some, but not near as much as if you have an overwintering species. And that's what you want to try to avoid, is having to try to till in or get a piece of a tillage equipment through a thick mat of residue, right? So you can still get some of the benefits of having a cover crop. They'll take up nutrients as long as they're growing. And then there won't be as much there to have to deal with. Also, in reducing the intensity of the tillage you do can help, right? So, you can imagine there's a big difference in between running a disc ripper down to 12 inches, 14 inches every single year, or maybe even a couple times a year, and running a lighter disc pass or a vertical tillage tool, right? So the intensity of the tillage that you do is important to consider there as well. Yeah. There are still a lot of things that a standard conventional planter can do, especially if it's, you need to consider your down pressure. You need to make sure it's running right and at the depth you set it at. And you might even start a little field with some of this and try it. I do believe NRCS may also have some cost share available for equipment modifications. And actually, Colin, I think you might have mentioned it as well as part of your grant. I think you said equipment modification in the beginning. Is that?
Yeah, that's correct. And so depending on, what watershed you're in and what programs being offered to you, it can differ from project to project. But for example, for our 319 project, we offered a 75% cost share up to, I think, $5,000 on an equipment modification. So as long as that equipment modification was specific to one of these best management practices, like implementing cover crops or doing some type of no-till or reduced till on IDEMS, and the Indiana Department of Environmental Management is kind of the limiting factor on what they see as appropriate. But yeah, we offered up to $5,000, and I know other groups with their 319 grants have offered up to $10,000 on equipment modification. So I would definitely recommend looking into your area and seeing what kind of programs are available, because more often than not, there is some financial assistance that could be utilized.
All right, thanks.
Yep.
So, Joe, I was going to just add a little bit to what you had said there too. The idea that, when we think about our planters and making sure that they're set up for no-till, like you said, there's a lot of different things that we can add on to any planter unit. So the key, like you said, is down pressure. Thinking about having enough down pressure evenly across that whole planter on the back. If needed, adding suitcase weights more towards the outer end of that field, or the bars that you put out, that helps add that weight out there in the back of the unit. Thinking about all the other things that you have mounted on your planter, if it's actually on the bar itself or on the row unit, because the more things that we have on a row unit, the more down pressure we're going to need, because those things are taking away from that down pressure of the double disc opener. And then another thing to think about, in these systems is that when we're working in a field that we've already tilled it before we've planted it, we're kind of pushing that easy button for that planter because it's not we're not having to worry about down pressure as much, or making sure that our double disc openers are as sharp as they need to be. So again, if you're thinking about trying some of these things, look critically at those pieces that you can address, with having really sharp or new double disc openers, that they are, properly set up, that, like Joe said, they're planting as deep as you want them to be planting. And then our no-till systems with cover crops, that might even be just even a little bit deeper than where we're typically used to planting. So really looking at that existing planter that you have, and then just looking at trying to adapt that planter to kind of fit your needs as you're learning more in that system. And then, like Colin said, those modifications that with that program could really help support that as you're trying this out. Does that sound good, Joe?
Yeah, it does. And then I just also would add that, we a lot of times we have to focus on right now because this is what we're living. But that if that's something you want to move towards, I don't imagine you're gonna run that planter for the next 30 years, right? Certainly maybe you're hoping to, and I know nobody's excited about having to buy a new planter, but but as you phase in new equipment, if you want to be moving into a different system, then just keep that in mind as part of your equipment purchasing plan as you phase in new things.
Yeah.
That can be a great way to step towards it. And we have a question in the chat too, along a similar line. Will dry fertilizer that is applied to the surface be adequately stabilized against runoff without a cover crop? And that is exactly, yeah. Jim, get the science answer on here. Just say it. It depends. So yeah, it really does though. And of course, it matters what dry fertilizer, if we're talking nitrogen or if we're talking phosphorus or potassium. It can be a little bit of a gamble at that point. And especially the tillage system matters a lot more there, because if it's dry fertilizer applied to a tilled loose field, then if you get a heavy enough rain and it washes that topsoil, you're going to lose the fertilizer with it too, right? So you want enough rain to sort of to activate that fertilizer and to get it into the ground, but not so much rain that it's going to wash off that field, right? And even in no-till, those residues will help to hold the pellets, and you may have a higher infiltration rate that will help to work that fertilizer into the ground with that rain. But if you're getting a heavy driving rain that causes a lot of runoff, you're just probably going to lose some of that fertilizer, right? So that's why we start talking about our 4 R's of nutrient management and timing. How important our timing is at that point, right? Because you want the right source, and you want an appropriate rate, and you want it at the right time. Because if you put fertilizer down and you get a 10-inch rain and you don't have a system that can handle a 10-inch rain, which is substantial, right? That's very difficult to do. They're all going to lose a little bit, and a lot of them are going to lose a lot more than others at that point. Yeah.
Joe, Jim, you got anything to add there? Any thoughts about it?
I think Joe covered it well. The key is, does the fertilizer react with the soil or get taken up before that runoff event occurs? And so you're hoping for a gentle rain that soaks in, and once the fertilizer reacts with the soil, as long as you don't have erosion, it's protected pretty well. But it's when it's sitting on the soil surface and you get a runoff event, that's where your big losses occur, which is exactly what Joe said. So sorry for repeating that.
That's high. This is recorded, right? I'm going to make that my ringtone. This is great. That's high praise.
I think that it's a really awesome thing to think about here, right? A lot of the things that both Joe and Jim kind of said is like, if we don't get a big runoff event, if we don't get a big rainfall, if we don't have erosion, now a bunch of ifs that associated with things that we don't have a lot of control over. And so then one of the things I just want to circle back to as I think about, then are there management practices that we can do to minimize those big ifs that we don't have control over, like the weather and when we have big rainfall events, and other things that we can look at to try to help support that system. And I think the question in the chat, Larry, I think you're right. If there are cover crops out there and they're actively growing, and that soil surface is more protected, that we have reduced our chances of a runoff event, right? We have increased the potential that those fertilizers are going to soak into the soil. And so again, thinking about how we can critically try to manage those aspects of farming so that when we do have large rainfall events or the potential that runoff is going to occur, can we try to create a situation on our farms where those things are going to occur less likely, and those fertilizers are going to stay there. So I think that's part of that thought in this process.
Mm-hmm. We have another question in the chat. How can we put these steps into walnut trees? I'm assuming for lumber production. And that is a good question. And those same principles that I covered can apply to perennial systems in addition to our annual cropping systems, right? So in minimizing disturbance, obviously you're not going to want to be doing a lot of full width deep tillage through trees, but you're going to want to make sure you're minimizing your chemical and your biological disturbances at that point. You're also going to want to make sure you're maximizing biodiversity. Right. So getting a diverse mix of plants in between those trees can help to create a more resilient system. And also then provide continuous living roots, right? So we've got some really great native plants that can provide a lot of wildlife and pollinator benefits that can fit really well in between all of those trees. And Colin, I don't know if your office does a lot with native plants. I assume so. And maybe you guys have some programs available for this sort of thing too. But you'll want to check with your local soil and water office. And Colin, I see you're on, so feel free to interrupt here.
I know they offer some assistance in native plantings, but that would be, you'd have to check with your local SWCD or NRCS to get the the specifics for your area.
But yeah, those same soil health principles apply even in perennial systems, even if it's not just an annual cropping system. Absolutely, yes.
Do we have any other kind of closing comments from any of the speakers or last minute questions or anything with respect to those?
Well, Joe hasn't said it yet, so I'm going to say it. I think when we were talking about those water stable aggregates at the surface, and I kind of briefly said it when I was walking through that demonstration of how to do that diagnostic, but I challenge every single one of you to go out and do that on your field. Not today. It's probably frozen to the very surface or covered with snow. But think about it right before planting or right after planting, checking to see if you do have water stable aggregates, and knowing that if you do, then you're more likely to have successful infiltration into the soil, which plays into, again, those nutrients soaking further into the soil. And again, water availability and stuff, and just really thinking about trying to build that more resilient ecosystem in the soil. So I had beat you to it, Joe, to challenge everyone in the session today to give that a try. And if they have any questions about how to do it, or would like to kind of do some larger assessments over multiple fields, there's ways that Joe and I can help out in when it's nicer out, of course.
Absolutely, yeah. And today here and I'm out of Lafayette, and it's supposed to get almost 40 and rain before the temperature plummets this weekend. So I'm probably not going to be doing a lot of traveling soon, but yeah, absolutely. If this is something you guys want to do, get a hold of your local office, NRCS extension, anybody, and they'll know how to get a hold of us if you don't want to reach out directly, and we can walk you through some of this. And I definitely try this on your own fields and see what you're getting, see what you have, and see where you need to head. But thank you guys for your attention. Thanks for hanging around.
Thank you.
Thank you to each of our 4 speakers today. I know you each have busy schedules, and so we really appreciate you taking the time out of your day to share this information. It's great information, so I really appreciate that. And for all of you in attendance, thank you very much for coming to listen, and hopefully you did learn something that you can take away and apply to your management system too. And like Stephanie and Joe said, they challenged you to try to implement some of the things that we talked about today. So just one last thing, I did record the session today, so we're still kind of hammering out the details on where and how that's going to be shared. I know for sure that we're going to share it on the Huntington County SWCD website. And so maybe share it on CCSI's website, or maybe through an email list here for the emails that we have on file for the participants. So if you want to go back and revisit the material and listen to what our presenters had to say, that option should be available here by the end of the day or tomorrow, hopefully at the latest first part of next week, once I get the video downloaded and uploaded and shared. So, but with that, thank you again to everybody who participated. Sheila and Ed, thank you very much for helping to organize the events. With that, I'll go ahead and bring the workshop to a close, and hope everybody has a good rest of your week and start gearing up for farming season here. So,
Thanks, everybody.
thank you.